Hey guys, so in this video I'm going to discuss question 5.15 from SC Gupta, page number 5.80. So this question has two parts. Part A and part B, and both of these parts are very different questions. So I'm going to solve part B first because it's a little tricky, and then I'll move to part A. A continuous random variable x, no wait, this is part A, wait. We are solving part B first. So this is for the PDF of random variable x given by fx is equal to 2 upon b plus x upon a plus b, where b lies between, where x lies between minus b and 0, and a minus x upon a plus b for x lying between 0 and a. Right, so the PDF is changing. So the PDF over the domain minus b to 0 is this, and the PDF over the domain 0 to a is this. So now we need to find the mean, median and variance, right? So let's just find the mean first. For finding the mean, we need to find x fx dx, right? But here what's happening, we can't just find this over minus b and a because our PDF is changing. So we need to define it for two different limits, for two different set of limits. We'll have two different integrals here. So x, and for the PDF 2 upon b into b plus x upon a plus b dx. For this PDF we have the limits minus b to 0, and adding this with, now my limits are 0 to a, so my PDF will change here, and I will have 2 upon a into a minus x upon a plus b. This is a dx, right? So let's just move now. So taking out 2 upon b into a plus b common from this integral, I'll be solving this integral first. So this is I1, this whole integral is I1, and this whole integral is I2, right? This is I2. So solving this integral, I1 first, 2 upon b, 1 upon a plus b. This gives me minus b to 0 x times b plus x dx, right? So solving this gives me bx becomes bx square by 2, and x square becomes plus x cube by 3, and my limits are minus b to 0. Again we need to multiply this by 2 upon b, 1 upon a plus b, or let me just write this whole again. So this is my constant term, 2 upon b, 1 upon a plus b, and this will become bx square by 2 plus x square, so x cube by 3, and my limits are bx square by 2 and x cube by 3, and my limits are minus b to 0, right? So this gives me I1 is equal to 2 upon b, 1 upon a plus b, and multiplying this. So if I put in 0 here, this gives me 0, this is 0, minus putting in minus b here gives me b minus b whole square by 2 plus minus b whole cube by 3, and this gives me minus this is minus b cube by 3, and this will become b cube by 2. So this will be b, this will be minus b, right? So this will become, so this will be 2 upon b, 1 upon a plus b, 2 upon b, 1 upon a plus b, and here I'll be having minus minus plus, so this will be b cube by 3 minus b cube by 2, right? Because this will be b square by 2, multiplying this with b, this becomes b cube by 2, this will be minus b cube by 3, because the power is odd here, right? So, and a negative sign outside, this will give me minus minus plus, minus this is minus, this is minus, minus minus plus, b cube by 3, and this is minus and positive, this will give me minus b cube by 2, right? So let's move to the next slide. So solving this I1 will give me 2 upon b, 1 upon a plus b, taking out b cube common, and this is 1 by 3 minus 1 by 2, 6, this will be 2 minus 3, minus this b and b goes away, I'll be left with 2b square upon a plus b, and a negative sign minus 1 here, so this will be minus 2b square upon a plus b. Now finding I2, this is 2 upon a plus b, 2 upon a plus b, x a minus x dx with limits 0 to a, this will be 2 upon a plus b, ax square by 2 minus x cube by 3, 0 to a, this is ax, so x becomes x square by 2, and this is minus x square becomes x cube by 3. After integrating, this gives me I3 is equal to 2 upon a plus b, so this will become a, putting in a first, this gives me a cube by 2 minus a cube by 3 minus 0, putting in 0 in place of x. Now this gives me 2 upon a plus b, this is a plus b, 2 upon a plus b, and the product of this. So 2 upon a plus b, this gives me, taking out a cube common, this gives me 1 by 2 minus 1 by 3, the LCM is 6, 3 minus 2, 1, so this gives me I2 is equal to, this is 3 minus 2, I'll multiply this by 3 and this by 2, this gives me 1, so this will become, and a goes away, I'll be left with power 2, 2a square by a plus b into 1 by 6, right? And I also had 6 here. This becomes 2 and 6 goes away, I'll be left with 3 here, so this will be minus b square by 3a plus b, and this becomes 2 and 6 goes away, I'm left with 3 in the denominator, this becomes a square upon 3a plus b. Now I need to add both of these, this will give me, this will be, so my mean is I1 plus I2, and my I1 was b square upon 3a plus b, and I2 was a square upon 3a plus b, so this gives me mean as 3a plus b into a square minus b square, which is a plus b into a minus b, and the denominator is 3 upon a plus b and a plus b goes away, and we are left with mean is equal to a minus b upon 3, yes, a minus b upon 3, a minus b upon 3. If I done everything correctly, let me just check. A minus b upon 3, we should be correct. Let me check my answer. Yes, this is mean is a minus b upon 3. Yes, we're right. So we need to find variance now, or let's find median first or variance. Let's find variance first. So the formula for variance is now we already have mean or mu dash 1. We already have this. We already have this. So we already have this. We need to find this. Again writing the formula for variance. So we have already found out this. We need to find this term. So now my fx was so I need to find this over the two different limits, and my limits are minus b to 0 x square. This is the PDF here was 2 upon b, a plus b plus x dx plus 0 to a, 2 upon a minus x upon a plus b into x square dx. So I'll be this will become my I, let's say this is I3, this is I4. So I'll be adding I3 and I4, and first let me find I3. For I3 I'll be just taking out 2 upon b, a plus b outside, and integrating this x square b. This gives me b x cubed by 3 plus this is x cubed, so this becomes x4 to the power 4. My limits are minus b to 0. I'm just using this formula. So the formula for integrating x to the power n dx gives me x n plus 1 upon n plus 1. I'm just using this formula here, so that you don't get confused. So yeah, so this becomes 2 upon b, a plus b. Wait, let me check. X square b x cubed by 3 plus x cubed x to the power 4 upon 4. So this gives me 2 upon b a plus b, which is 0 minus b to the power 4 upon 3 plus b to the power 4 upon 4. Right. How? When I'll be putting it minus b here, this becomes minus b cube, and this whole becomes minus b to the power 4 upon 3, and putting in minus b and the power being even gives me positive b and a negative sign outside. This ultimately gives me I3 as taking out b to the power 4 common, so this gives me 1 upon 3 minus 1 upon 4. 12 will be my LCM. 2 upon 12, 4 minus 3 1, so 2 upon 12 b cube upon a plus b, which gives me b cube upon 6a plus b. So finding I4 now. I4 was integrating 0 to a, 2 upon a plus b, a minus x into x square dx, which is 2 upon a plus b comes out. This gives me, integrating this term, this whole term gives me x square, so ax cubed by 3 minus x cubed, so minus x to the power 4 upon 4. My limits are 0 to a. This gives me I4 as 2 upon a plus b into a to the power 4 upon 3 minus a to the power 4 upon 4 minus 0, which gives me 2 upon a plus b, taking out a to the power 4 common, 1 upon 3 minus 1 upon 4, 12, 4 minus 3, 1. So this gives me I4 as 1 upon 6a plus b. This goes away, this gives me power 3. So this gives me ultimately a cube here. So this is 1 upon 6 a cube upon a plus b. Now adding, so this is adding I3 plus I4, which gives me, taking out, wait, let me just add this, b cube upon 6a plus b plus a cube upon 6a plus b. Now adding both of these, taking out 1 upon 6a plus b common. Now using the identity for a cube and a cube plus b cube, a cube plus b cube is equal to a plus b. Now I'm just writing the identity here. A cube plus b cube is equal to a plus b into a square minus a b plus b square. B square minus ab, a square. Or let me write this clearly. A cube plus b cube is equal to, I'm just writing the answer down below, a plus b into a square minus a b plus b square. Okay, a plus b minus a square minus ab plus b square. So a plus b and a plus b can go away. Let me write this, a plus b into a square minus a b plus b square. This goes away. Now I'm left with mu2 dash, the second moment with respect to the origin, or ex square, is 1 upon 6 a square minus ab plus b square. Now finding the variance, which is mu2 dash minus mu1 dash whole square, which is 1 upon 6 a square minus ab plus b square minus the square of 1 upon 3 a minus b, and the square of this whole term. This gives me variance as 1 upon 6 a square minus ab plus b square minus 1 upon 9. Now a minus b whole square, opening this, a square plus b square minus 2ab. Now 6 and 9, what can be my LCM? It will be 18, so this becomes 3, multiplying this whole term by 3, 3a square minus 3ab plus 3b square. Now 9 2s are 18 and 6 3s are 18, so I multiplied this by 3 and this by, I'll multiply this by 2, so this gives me minus 2a square minus 2b square minus minus plus plus, and 2 and 2 4 plus 4ab. I'll be left with 3a square minus 2a square, so I'll be left with a square here, and minus 3ab plus 4ab, so plus ab, and 3b square minus 2b square plus b square upon 18. So this should be my variance, this should be my variance. And are we correct? Yes, this is our variance, a square plus ab plus b square, a square plus ab plus b square upon 18. So my variance is, let me write this again so that you guys understand. I'll be writing the formulas also. So variance is ex square minus ex whole square is equal to mu2 dash minus mu1 dash whole square or 1 upon 18 a square. This is the answer in our case. So plus ab plus b square. Yeah, so now we need to find the median. We found the variance, we found the expected value. Now we need to find the median, right? So the PDF that was given to us was, I'm just writing the PDF again, 2 upon b 1 upon a plus b into b plus x, right? So my limits are and 0 x a 2 upon a right. So these are my domains and two different and the PDFs on the respective domains. So now let me compute the CDF, right? So the CDF, or the cumulative distribution function, the cumulative distribution function fx, which is just, for example, if x lies here and this is minus b and this is x, so this CDF fx will give me this whole area from minus b to x, right? X is any number between minus b and a. So for example, case 1, the CDF when x lies between, x belongs to minus b case 1 when x belongs to minus b comma 0. So CDF over here. So for finding the CDF fx, this will be just integrating this from minus b to x, and we'll take this PDF because my domain is this. I have to find the domain. So finding the CDF 2 upon b 1 upon a plus b. I'm finding the CDFs first and then I'll be finding my median. So 2 upon b 1 upon a plus b, this becomes integrating this bx plus x square by 2, and my limits are minus b to x. Two upon b 1 upon a plus b, 2 upon b 1 upon a plus b, so this is bx plus x square by 2 minus b square positive b square by 2, right? So this whole expression becomes bx plus x square by 2 plus b square minus b square by 2, which gives me my CDF fx as see, now what I did here was I just substituted x here, so I can tweak this PDF just so that you don't get confused. So let me just write this as b plus t dt. Let me write this as t, and then I'll be substituting x here. So this is b plus t dt, which is equal to 2 upon b 1 upon, this is t and this is also t. So this is bt plus t square. T is just a variable I am using so that you don't get confused with x and t. So this is x and x, so this is bt plus t square. Let me just write this again. So this is bt plus t square by 2 minus b to x, and this becomes substituting x in place of t, bx plus x square by 2, bx plus x square by 2, yes, minus b, now putting in minus b in place of t, so this becomes minus b square, and positive b square by 2 because this is t square by 2, so putting in minus b whole square upon 2, so this becomes b square by 2, this becomes plus b square minus b square by 2. Ultimately this gives me fx as 2 upon b a plus b and this whole becomes bx plus x square by 2 plus b square by 2, right? Bx plus x square by 2 plus b square by 2. So yeah, this is my PDF when when my x lies between minus b to, this is basically from this is from minus b to x, right? So if I want to find this, right, if I want to find the CDF, if I want to find the CDF of 0, f0, so this will be fx dx minus b to 0, and I have already found the expression for x, so I'll be just substituting 0 in place of x, so this becomes f0 implies 2 upon b a plus b, and this is 0 into b square by 2, 2 and 2 goes away, b and b goes away, this becomes b upon a plus b, right? Now I'm going to find the CDF when my x lies between, when x belongs to 0 to a, when x belongs to 0 to a, I'm going to find my CDF, which is f of x 0 to a, 2 upon 0 to x. CDF is denoted by a capital F and PDF by a small f. 2 upon a, 1 upon a plus b, a minus x dx. So this becomes 2 upon a plus b, a x minus x square by 2, 0 to a, which gives me 2 upon a plus b, a square minus a square by 2. See, I made a mistake here. Why did I write a here? Again, that's why I should be representing this by d by t, right? So this is again wrong. Let me write this again. So this becomes t, right? So this is a minus t. My PDF is a minus t and dt. At minus t square by 2, 0 to x. So this gives me a x minus x square by 2, ax minus x square by 2 minus 0. So this becomes 2a upon a plus b, ax minus x square by 2. So this is not my CDF over 0 to a. I'm missing something. What I did here, finding the CDF from any number lying between 0 and a, I would need this area also, and plus, for example, my x lies here, right? So this area. So we found this area using this expression, but we also need this area, right? So we need f of 0. So I'll be just adding f of 0 everywhere here. So plus f of 0 plus f of 0 plus f of 0. So my final expression for the CDF of any x lying between 0 and a becomes f of 0 plus the area from 0 to a plus the area of any x lying between 0 to a. What does this show me? This shows me the area under the curve from the lower limit 0 to any number x where x lies between 0 and a. Right, this shows me the area under the curve from 0 to x where x is any number lying between 0 and a. Right, now for finding the CDF I also need the area prior to 0, which is f of 0, the CDF of 0. So I need to write this. I missed this, so I wrote this. Right, I wrote this at the end here. Yeah, I wrote this here. So this is f of 0, f0, f0, f0. Right, let me just check if my recording is still on. It's stopping in between. Right, so yeah, so this gives me, and f of 0 was b upon a plus b. Right, so this expression becomes, I'm writing f of 0 first. So my f of 0, I just, we just calculated this, b upon a plus b, b upon a plus b. Right, so I'm just writing b upon a plus b first because it has come first. So b upon a plus b, this is f of 0 plus this area from 0 to any x, area under the curve from 0 to any x. So this will be 2 upon a plus b into ax minus x square by 2. So now we have the CDFs over the different domains. Now let's assume that my m or my median lies between let m belong to minus b to 0. Right, so now I just need to prove that fm is equal to half, because what does median show? Median just shows me that the area before this m, which is my median, m is my median, the median shows that the area under the curve from the lower limit to m is equal to half, or the probability prior to m and after m is equal to half. Right, so it is it is dividing the distribution into two equal parts. Right, so this is half, fm is equal to half, or I can write this as, in probability terms, if I write this shows me that x, any number less than equal to m is equal to half. Right, so when my m lies between minus b and 0, when my m is lying between minus b and 0, so my CDF for any number x lying between minus b and 0, so any number m lying between minus b and 0, was f of x is equal to b upon, f of x was 2b upon a plus b. We just found this earlier. Right, see, any x, this is a CDF for any x lying between minus b and 0. 2 upon b, a plus b into bx plus x square by 2, bx plus x square by 2 plus b square by 2. Right, so now we just need to put m here and equate it to half. 2b, this becomes bm plus m square by 2 plus m square by 2, which is equal to half. Right, this is not m square, this is b square. Okay, so now we need to find this equation, the answer to this equation, and this will give us our median m if it lies between the domain minus b and 0. So this gives me 2b upon a plus b into bm plus m square by 2 plus b square by 2, which is equal to half. 2bm Just taking the LCM here, 2bm plus m square plus b square gives me 2a plus b, and 2b goes here, cross multiplying it, 2 and 2 goes away. This gives me 2bm plus m square plus b square is equal to a plus b upon 2b. Multiplying 2b here, 4b square m plus 2b m square plus 2b cube minus a minus b is equal to 0. So solving this equation will give me a certain value of m. This is a quadratic equation. So let's just find the b square minus 4ac term here. Just checking the discriminant here. Just checking the discriminant here. Four b square minus 4 into a is my b is 4b square whole square minus 4a is 2b, and c is 2b cube minus a minus b. So this is 16b to the power 4 minus minus 4 into 4b to the power 4, 4b to the power 4 minus 2ab minus 2b square. This gives me 16b to the power 4 minus 16b to the power 4 plus 8ab plus 8b square. This goes away. This gives me 8ab plus 8b square. Let me just check. 4b square whole square minus 4 into a 2b into 2b square 2b cube minus a minus b. So this becomes 4b to the power 4 2 minus 2ab minus 2b square. Now opening my this bracket, 16b 4 goes away, plus plus, right? So this is greater than 0. So my discriminant is greater than 0. This gives me m is equal to minus 2b plus minus root of 8ab plus 8b square by 2a, and my a was 2b. I wrote this incorrectly. This is 4b square. So this is 4b square. And this is positive. This gives me minus b, 4 and 4 goes away, and b goes away, minus b plus minus, and I'll just take this 16b square inside, 16b square and 8ab plus b square. 8 and 16 goes away. This gives me m as m is equal to minus b plus minus root half into a plus into ab plus b square upon b square. B and b goes away, a plus b. Right, so I'll be rejecting this value where I have minus b minus, because my m should lie between minus b and 0. Therefore my m can be minus b plus half a plus b upon b, right? This can be my value. Now I need to also check if my m lies between 0 or a 0 and a. I need to check if my m lies between 0 and a. This is quite lengthy. Are you able to see me? I don't think so. Let me just switch on my light. So might be able to see me now. There is some issue related to my lighting. Are you able to see me now? I don't think so. Let me. Sorry. Right. Yeah. Yes, so let me find the other values for m. Now let m belongs to 0 and a, so I already calculated the CDF for any x lying between 0 and a, the CDF, right? Because if m lies between 0 and a, if m lies between 0 and a, and the area on the left hand side of m is half, then that means the CDF of m should give me an area equal to half, and I need to include this area also, right? So m, this, for example, if this is a and this is b minus b, so I need to include this area also and this whole area, right? So I calculated my CDF earlier for any x lying between minus b to I calculated my CDF for any x lying between 0 and a, so I need to calculate this now. I have the expression here, right? Where is my expression? Is this my expression? Yes, this is my expression. I added f of 0 here, so this gives me b upon a plus b. So this is equal to b upon a plus b, b upon a plus b, b upon a plus b into b upon a plus b plus 2 upon a plus b ax minus x square by 2, ax minus x square by 2 plus ax minus x square by 2 into 2a upon a plus b, right? So this is my CDF. So Fm should be equal to half, and putting in m in place of x gives me b plus a. This is f of 0, this is the CDF of 0, right? So this will come as it is 0, and this expression gives me, this whole expression gives me the area under the curve from any x lying between 0 to a, where my lower limit is 0, right? So this gives me am minus m square by 2 into 2 a plus b, right? So this gives me fm is equal to b upon a plus b, and this should be equal to half, right? So this becomes 2am minus m square by 2 this should be equal to half, right? This should be equal to half. So what I can do is that I'll be multiplying a plus b both sides. So this will give me b plus 2am minus m square by 2 into 2, and I multiplied a plus b on the LHS and the RHS, and this gave me this term, right? And I have an a here, 2 and 2 goes away. This gives me 2b plus 4am minus 2m square is equal to a plus b into my a, and this will be this, I just multiplied a here and I take a to the RHS into a, right? So this gives me 2ab plus 4am minus 2m square is equal to a square plus ab 2m square minus 4am minus 2ab plus a square plus ab plus plus a square plus ab plus 2ab, right? Plus a square plus ab, yes. So this is 2am minus 2 and 2 goes away, and I already have a 2 here, yeah. So this is equal to 0, so this becomes 2m square minus 4am minus ab plus a square is equal to 0. Solving this equation gives me m is equal to minus 4 plus 4a plus minus root 16a square minus 4 times 2 and a square minus ab, which upon 2a which gives me m as 4a plus minus root 16a square minus 8a square plus 8ab upon 4 and 4 goes away, a plus minus root, and I just take 4 inside, this becomes 16, so this gives me a square, this should be 2, so this is a square minus half, because I just took 4 inside the root, so this became 16, and 8 and 8 goes away and half is left, so this becomes half a square plus half ab. So let me just go to my next page. I could have just cancelled 16m square minus 8m square. I would have been left with 8m, but I didn't do that. Don't know why. Would have made my calculation simpler. So this is a square. This was 16a square minus 8a square. This is 8a square, but I am subtracting this here. So a square minus half a square. This becomes half a square plus half ab. Half, taking half common, half a square plus ab. Now I can take a also common. Now I cannot have any m which is greater than a, because my limit for m was, my domain for m was that m should lie between any m lying between 0 and a was actually my upper limit, so my m cannot cross that. I'll be rejecting the a plus this value, and I'll be left with m is equal to a minus root half a into a minus let me check if I made some mistake or not. Minus 4a, this is minus 4a minus plus. So let me check my answer. Yes, so they have given the median as this value, right? But I calculated one more value here, so I gave you two values. I feel you need to check the other value also. If they would have given us some specific values of a and b, then we could have put them and substituted them and checked if which one is the correct median, right? So I calculated both of these values, this and this. Yeah, so they have only written this solution here, right? But I feel you needed to solve that part also, and if they would have given us specific values of a and b, then you should have substituted them and checked, right, which is the correct which is the correct median, right? So if this comes in your exam, calculate both of these values and show them, right? So we found mean, median, and variance. Now we need to proceed with part A, right? So I'll just stop this recording.